There is a major concept within the area of multi-objective, which is the Pareto optimality, which was first stated by Wilfredo Pareto in 1996, according to which no individual or preference criterion can be better off without making at least one individual preference criterion worse off. So that statement led to the definition of optimality in terms of Pareto, which says that in the optimization context, a feasible solution is efficient. We can also say it's Pareto optimal or non-dominated when no other solution exists which is better for one objective without being worse in some other objective. So that's the way to define a Pareto optimal solution, but we can define the, the opposite, which is a dominated solution, which is a solution that exists if there is another one that is at least not worse for all objectives and better in one or more objectives. So there's a way for an overall, let's say, improvement from that dominated solution because we can improve one of the objectives without worsening any of the others. So there's no reason for us to stick to that solution because we can attain another one which is, we say, dominated because it's better in at least one objective and not worse in the rest. So let's see an example. Let's imagine we have three companies, company A, B, and C, and we have information regarding their income, their dividends, and some KPI regarding their solvency. So let's see that we have an income of 200, 150, and 150 for these three companies, dividends 40, 40, and 60, and solvency is 1.5, 1.5, and 1.25. So the higher the value, the better the objective, let's say, or the criteria. So we can see that company B is a dominated solution because there is at least another one, which is company A, which is not worse in any of the objectives, but it's better in at least one of them, which is the income. So if we have we thought of picking company B, we could move to company A and we would improving. So we would not worsening any of the different objectives, but we would improving. We would be improving at least one. So B is dominated, we say, by company A. And company C is a non-dominated solution because let's recall the definition. No other solution exists which is better for one objective without being worse in some other objective. So there's no way to improve one without worsening the other. So let's compare it with A. So we need to make sure that there's no other solution meeting that requirement, and we only have two other solutions, which are A and B. And A has better income but worse dividends, and B has better solvency but worse dividends. So it's not the case with C. It's not the same as it was with A. So if we move to A, we are worsening a solution starting from C, or if we move to B starting from C, we are worsening the dividends. So this is non-dominated solution. Okay. So among all the solutions we have for a problem, we have feasible solutions. Those are that meet our requirements. Those which are not feasible are those that, in terms of mathematical programming, they might satisfy only some constraints. So, they are solutions we cannot put into practice. And among those feasible solutions, we have the efficient solutions or the Pareto optimal solutions. So we need techniques that allow us to first discard infeasible or non-efficient solutions. So we need to go to this orange rectangle and identify them. And once we have this, we need to use our criteria to decide which of those efficient solutions we prefer, because there's no objective argument to decide which is best among those efficient solutions, but we just need to resort to the criteria of the decision maker. Okay, Let's see an example which is a classical one. If we need to compare solutions, let's say if we are designing the supply chain of a company or any kind of in any kind of activity where we have cost and where we have customer service, first we might try to find the minimum cost we can have. So we forget about the customer service and we try to satisfy all requirements uh, corresponding to the situation, and we try to minimize cost, and we get this number here. So this horizontal line here is telling us that there's no way for us to find solution in this area. It's forbidden because there's no way to find them, so these are invisible solutions. On the other hand, if we try to maximize customer service, forgetting about cost, so we are willing to pay as much as needed, if we get the maximum possible customer service, we would reach this point here, this value here, and this vertical line indicates us that we cannot move beyond that. So those solutions here to our right, to the right of this line, are solutions we cannot attain because they are beyond the maximum customer service we can obtain. So this rectangle here and this rectangle here and the intersection indicates us that these are solutions that are beyond our grasp. Okay? Next, once we have that, we might try to find which are these points A and B and the Pareto fronts, which are the non-dominated solutions. So imagine we have the solution with the minimum cost. We might have obtained a solution somewhere here, because if we are only taking care of minimum cost, we might find a solution within this line. So the next thing we need to do is to get the maximum customer service for that minimum cost. Okay, there's another example where I explain this in more detail for a particular case, which is a portfolio selection problem. But the point is, there's a point B here, which provides us with the minimum cost, and given that minimum cost allows us to have the maximum return. And the same for point A. Okay, if we want to maximize customer service, we might find different solutions with the maximum customer service with different costs, but we would like to get point A, which is the one that provides us with the maximum customer service, and for that customer service gives us the minimum cost. So this is the values we are aiming for, so that we can have A and B. And once we have that, which are the extreme points, we would like to have all the points in between. So that, for example, for any point here, okay, let's use the point, okay, for any point here, this solution I'm selecting right now, okay, anyone that is on its vertical line is a solution that for the very same customer service is more costly, so it's dominated. And those which are here to our left, okay, are solutions that for the very same cost provides us with a less, a smaller or a reduced customer service. So they are dominated, and the same goes for the rest of the area in white we have here. So for any point you select here, you can go down or you can go right and find a solution which is non-dominated, and it's better objectively than the one you can pick in this white area. So we have divided the uh, whole area of different solutions in those which are invisible, the orange ones, those who are dominated, and those who are not, the non-dominated, which is also called the Pareto front. So this is our objective, and it's the manager or the decision maker decision. It's a his or her call to decide whether he or she wants to be closer to point B or closer to point A. Okay, but this is something with which uh, the techniques can assist the decision maker, but the ultimate decisions corresponds to whoever is aware of how the system is. Okay, and The thing is, what I want to highlight here is that we need numbers. In the case of the customer service versus cost, we can have useless statements like, okay, I would like to provide maximum customer service with a minimum cost. That is saying nothing, because of course we want that. So we need to get rid of those kind of approaches, because that doesn't make sense. And we can move to what we might say are obvious statements, like, I would like to have the right trade-off between maximum customer service and the minimum cost. This is something obvious, but also it doesn't lead us to making a decision. But if we had numbers, if we have for every possible cost we can have, which is the maximum customer service we can provide, or the other way around, for the different options we have for the customer service we can provide, the cost that we need to have for that customer service, that allows us to make a decision, and that's why these approaches are variable. Okay. So in all, there are very often several criteria or objectives, and we may have many options. In that case, we would be within the realm of the multi-objective approach, or a few of them. In this case, we are in the criteria realm, and we have to choose from them. And the concept of optimal becomes very blurry because there's no way to solve them in an objective manner. So instead of aiming for the optimal solution, we try to obtain other Pareto optimal solutions, which we called also non-dominated solutions, and after that, we try to find the right balance according to our preferences. So the numbers are in assistance, or are an assistant the decision maker to make a stand, but it's his or her who should decide which of those solutions is the one that he or she wants to implement. So I hope this helps you to have some very basic ideas about how multi-objective and multi-criteria works, and serves as an introduction to it, from which you can start and learn more, which is something that might be of help. Thank you and goodbye.